In this video, we're going to be testing a claim about a proportion, and we're going to be using the p-value method. This is the formula for this test statistic, but we're not going to use the formula. But if you want to, this is what each part of the formula means. We're going to be using a calculator to find our test statistic. So for this example, when testing gas pumps in California for accuracy, fuel quality enforcement specialists tested pumps and found that 1,299 of them were not pumping accurately, and 5686 pumps were accurate. We're going to use a 0.01 significance level to test the claim of an industry representative that less than 20% of California gas pumps are inaccurate. From your perspective as a customer, does that rate appear to be low enough? So we'll come to that at the end. So we know that we're using a 0.01 significance level, and we are testing the claim that the less than 20% of gas pumps are inaccurate. So let's start off with our hypothesis test. So the proportion is going to be equal to 20% or 0.20, and the alternative, and it says less than 20%, so we're going to say less than 0.20, and we have an alpha value of 0.01. We also know that we have 1,299 pumps that are inaccurate and 5686 pumps that were accurate, and we're testing for inaccuracy. So our X value here is 1299, and N is going to try and trick you, because normally we just jump for the biggest number, and that is our N value. But this is the pumps that are accurate. N should be the total number of pumps, period. So those that are accurate and those that are inaccurate. So you're going to take 1299 and add it to 5686, and you're going to get 6985. So we have everything set up and ready, so we're going to go in and find our test statistic and our p-value, because this is the p-value method we're using today. So we're going to go to just going to go to stat and tests, and we want to do, because this is a proportion and we have one thing we're dealing with, we're doing a 1 prop z test. And so our p-value, our p-naught, is going to come from our hypothesis. So p-naught is going to be 0.20. So 0.20, x is going to be 1299, and n is going to be 6985. Our alternative hypothesis says less than, so that's what we're going to select here, is less than. And then go down to calculate, hit enter again, and we're going to get a t-stat here of negative 2.931. So z equals negative 2.931. And we also have a p-value of 0.0017. So 0.0017. Now we don't need the calculator anymore, so just remove that. And since we're using the p-value method, we're going to compare our p-value to our alpha value. So 0.0017 is less than 0.01. Since our p-value is less than our alpha value, we can say that we can reject the null hypothesis. So now that we have rejected it, we need to actually state our answer in a sentence or two. So, zoom out a little bit. And I'm going to type in our answer here. So since we reject the null hypothesis, we can say that there is enough evidence that supports the claim, and the claim says it's less than 20%. So we have enough evidence that supports the claim that less than 20% of gas pumps in California are inaccurate. Now, the second part of the question asks, you look at this information, and does that rate appear to be low enough? I don't know about you, but I look at and see that 1,299 out of 5,600 are inaccurate, or 1,299 are inaccurate out of almost 7,000, not 5,600, 7,000. That seems to be just a little bit too high for my tastes. So from my perspective, does that rate appear to be low enough? I would say no, it does not seem low enough. I would prefer for it to be closer to 0%. I would like my gas pumps to be as accurate as possible all the time. So that's just my opinion on it, but this is how you would go through a question like this.